And welcome to our bonus feature segment. We've got a bunch of more data to blast through here at the Smash News Network. Least busted name in news. Let's do it. We're looking at cosmic ray data here from the Apatit and Barentsburg neutron monitors. So we see a minor uptick here over the past 30 days at the Apatit neutron monitor. Barentsburg, flat over the past 30 days at Barentsburg. Let's go farther south to Athens, Greece. There's the cosmic ray situation at Athens, also flat over the past 30 days. How about even farther south? We'll take a look at Mexico City. Mexico City also flat over the past 30 days. Let's go farther north once again to Oulu, Finland. There's Oulu, Finland's neutron monitor. Slight uptick there at Oulu over the past 30 days. DOMB Antarctica, mostly flat, a slight downtick at DOMB. DOMC, similar to DOMB, a little bit more on the flat side. That's our little cosmic ray update. By the way, if you want to learn more about things like solar minima and what's grand about solar minima when they are, we've got a thread about it on our smashamash.com/forum website. There's a forum thread there entirely about the sun. And if you want to see proxy data on the past 1,000 years of solar activity, check it out. smashamash.com/forum. Next, looking at the total electron content forecast. We are seeing a little bit of chaos here. Also some charging hazards happening. We'll get to it in a moment. We're going to let this play through a second time here. The total electron content forecast is showing you the coupled thermosphere, ionosphere, plasmasphere electrodynamics. When your GPS satellite must communicate through a lot of free electrons, it can be off by thousands of miles, as most people who live around the equator are aware that their GPS will typically only work at nighttime. So that's what you're looking at there. Distances are shown here in miles. That's the electron content in between your GPS satellite, located at about 12,500 miles of altitude, and your handset. So we've got some charging hazards. They've subsided a little bit here since we did show prep. Charging hazards there around the Central Pacific. Surface charging, it won't cause a whole lot of harm or communications breakdowns with your satellites. Here's the one-year chart of the relativistic electrons from Solon.info to put that in context. And here's the 3-day chart, and we're seeing cratered levels of electrons, which we typically see accompanied with coronal hole wind streams. So we've covered it for a couple of years now. It's a regular feature of coronal hole high-speed streams. That's your GOES 16 and GOES 17 electron flux measurements. Here's the forecast model. We saw a little bit lower levels there than were forecasted. The green boxes are the forecast, the yellow diamonds are the observation. Let's take a look at the ionosphere next, located at about 300 kilometers of altitude. That's where the F layer is located. And here's the ionogram for the past day. By the way, if you think these ionosphere videos are able to forecast earthquakes, sorry to say, folks, that they're not. The resolution here is only 1 megahertz, and that is not sufficient to forecast earthquakes. Plus, the signal that occurs gives about 10 days notice, which means there is zero predictive value, especially in such low resolution imagery of the ionosphere, to use this to forecast earthquakes. It will simply not work, and there is no science publication to suggest that it does. Let's bring up the latest images. There's 12 o'clock universal time on the ionogram, and there's 12 o'clock universal time on the anomalygram, showing anomaly in megahertz from the 30-day median. We are seeing a high-frequency anomaly here, stretching from Central Africa around to where the South Atlantic anomaly is, which is right about here, the weakest point in Earth's magnetosphere. If you enjoy the content, press like and subscribe. I don't know what else we could possibly do to get this content onto people's screens. Maybe tell your friends and foes about us. Press share. Maybe one day the algorithms will actually recommend the videos to the appropriate parties. If you're not on Twitter, thanks to our new followers over there, by the way. If you're not on Twitter, get on Twitter. Make an account. I mean, it's just spectacular. We've got over 10,000 tweets, and we won't show you what's on there. You'll have to create an account to figure that out. Twitter.com/SmashAmash. Welcome to the Neo Renaissance. Congratulations on realizing we exist. Did you know we're writing a publication to explain the mechanism underlying the solar polar field reversal and hence sunspot cycles? Visit our links at smashamash.com. Become a member of the Smash team if you prefer to see the content remain publicly visible and free for all to view. Thanks to the Smash team for helping us out over all of these years. We've been making these videos for over 4 years. Also, if you'd like to pick up some merch, you can find links at the smashamash.com homepage or on the Smash team page to Smasho merch. We've pared down the choices. We've sorted them in order of best selling. By the way, if you're going to pick up any merch, use the promo code 20flash20 to save 20% before it's gone, and it'll be gone by tomorrow. Continued bonus features are the ground-based solar observatory at El Teide, Spain. So here we may be able to see which filament has erupted, causing the coronal mass ejection we showed in our last video. Make sure you check that out if you haven't. We've been doing 3 daily space weather videos. And not exactly sure. The CME, oh, it's this filament right here. You can see this filament suddenly vanish. That actually headed off in this direction, believe it or not. We're expecting it to miss Earth to the southwest. Next, the latest colorized magnetogram and solar intensitygram. There's 29, 54, and 55. Slightly to the northeast of that, we'll find sunspot 2956, which is much more likely to produce solar flares, as it is a beta-class sunspot. There's 2958, also more likely to produce flares. I believe that's grown since we did show prep. And there's 2957. So the likelihood of solar flares has gone up quite a bit. Here's a recap of that in magnetogram. Here's 2957. Certainly beta class. Is it moving toward beta gamma class? Let us know in the comments what you think. There's 2958. That's a little bit less complex, I think. There's 2956. And there's 2954 and 2955. We've also got the GOES 16 SUVI with its fantastic wide field of view. It's great at showing solar prominences. We stream it regularly on the Twitch channel at twitch.tv/smashamash. Perhaps install the Twitch app. You'll be able to see when we go live, and we do regularly on Twitch, thanks to our Twitch viewers. And we'll close out with my favorite wavelength. If I had to pick one single wavelength, it would probably be 171 angstroms. Fortunately, the SDO has lots more to offer. So once again, thanks for tuning into the channel, and may that solar wind be at your back.